So, mythological Nordic bridge, aka Bifrost, aka a little bit of Houdini for Meyer, but just a little bit. So Bifrost is a quiet new tool set. So disregarding my sarcastic comment right now, um, nobody should expect this to be Houdini in Maya. But Bifrost is actually a cool tool set. If you think about it and if you dive deep into it, it's a little bit problematic that there's not really that much documentation about it. And you pretty much have to know the same workflows in other VFX packages to actually use Bifrost, or you have to have worked with ice in XSI, or you might have to have some programming experience or some Houdini background to actually kind of get the grasp of it, because there's really not that much documentation. They are slowly starting to add some things there, but still it's a bit messy, and you really a lot of things that you should have in the base package are actually just downloadable as a things like the Rebel pack and so on and so on. It should be really be in the base package, but it's on version 2.1. It has been used on production. It can be used on production. It's a really, really, really modern and actually fast tool set. So it can do a lot more than the little fire and smoke sim that I did, actually. A lot more. And it's a lot more powerful. It has its quirks at the beginning. For example, obviously, for some reason, you can't, for example, if you cast something out, you can't offset the read, so you can't offset your cache read, and whatever you try to do, you can't. That was one thing that nearly drove me insane, and I went in and renumbered my whole exported BIF file sequence to do that. So before I go on a rant here, I'm gonna let me just say it's a pretty individual tool set sometimes, but again, it's a new tool, and they really put a lot of work into it, and it's actually usable in its state as it is. So I was actually impressed how fast some of the sims turned out, and really the sim that I did for this asset is really not complicated. But yeah, it's compared to the old Maya fluids, which you can still use, but they're slowly being phased out in a way. So Bifrost will in the future probably replace half of Maya's toolset, and if you ask me, they can't move fast enough to actually do that, because some things in Maya are just old. They still work. They still work a lot better than some other packages, but it's showing its age, really, and Bifrost is gonna change that. The usability is the thing, as with always in Maya, where things are a little bit problematic, because, well, if you don't have a team of some programmers basically working on reducing the issues you have as a user experiencing the toolset, you're pretty much stuck with a lot of frustration. But enough of that. As I said, in this case, I was pretty happy to not have to leave Maya for the sim, because usually I would do that sim in Houdini, and a lot of you would probably also use Houdini or any kind of plugin in any host package, really, to create that. And it's for simpler things, and the smoke sim is pretty simple. It's quite handy to not having to leave your base package. So even though I ranted a little bit again, it's worth a shot to try to do things with Bifrost, and it's only going to get better in the future. So Autodesk pretty much knows that there's a lot they have to improve on the tool set, I'm sure, and they will over time, and hopefully this happens fast. So yeah, let's take a look at that and how I decided to build that. As I said, I'm not going to go into the deeper levels of Bifrost, but I'll do a quick overview, and maybe that will inspire you to test out the tool set for yourself. So yeah, let's get started. As you can see, there's another thing that we have not yet explored, and this is actually hidden, and it's hidden so it doesn't evaluate. So because I don't want to have my smoke sim running while I'm animating the thing or showing you the rig. Let me just quickly turn on the textures here again because they didn't reload on loading the file. So let's take a look at the thing we want to take a look at, and that is the P51D sim group. So let me just turn that on. So before we take a look at the actual smoke, let me just quickly go through what's in here. So we have this P51D BIF object. That is the output of the simulation. This is what is holding our smoke, and that is the output of the P51D Bifrost exhaust graph. So that's the thing that's actually holding our Bifrost simulation. I can't parent it to anything because this is just a node that exists in the scene, and it's the actual Bifrost node graph. So there is this collider. So obviously the smoke, if it's emitted, has to collide with something. And as you can see, there's a pretty simple collider. So it just took parts, some surfaces of the plane, combined them to a mesh, merged some vertices and reduced it basically, and added a little cube because I noticed that the smoke might need a bit more of collision surface back here to not maybe interpenetrate the wing at the back here. It actually never did because it's dissipating long before that. The plane doesn't make that much smoke in reality. So as you can see, this is just the collider for the right side. So I kind of set up the sim while looking through my shot cam here, and just set up one side because in the end, this is just a simple simulation. And as I said, if you were working on an actual shot, you would probably have people working on that in a different package or maybe in Bifrost, but you would concentrate on that sim while somebody else is going to do the rest of the shot and the animation and everything. So yeah, I just use the right side. So because really, if you need smoke on the other side, you can just mirror the output of the sim that it's there, because really it's not that much smoke. So if we take a look at the actual shot that I rendered, you can see it's really just a little bit puff of fire and smoke. So because the real plane doesn't make that much smoke, actually it doesn't make that much fire in reality. So sometimes it does, but really seldomly. So there's usually much more smoke than there is fire, but it's a VFX shot, so more fire. Yeah, so that's that. I'm gonna hide the colliders again, and the other thing we might want to take a look at, let me just quickly show everything again here, is the emitters. So those are just these little cylinders in the Merlin engine exhaust ports right here, and we definitely don't want to see them and render them, but they are what is generating our smoke at the end. And the way this is set up is that the simulation is always going to be at the origin. So this position basically is always what is simulating the sim, because after all, this engine smoke is only ever going to exist when the plane is on the ground in exactly more or less this position. So the actual output object is then transformed with the rig, so I can move the plane basically. I should move that. Can basically move the plane anywhere I want, and the sim will follow. So you would do that differently on production, definitely, because you would basically simulate in place, because there might be a few planes starting their engine and the wind will be different wherever they are. So you basically would maybe, it depends. So sometimes you only ever simulate one cache and you're going to reuse that cache a lot of times and just give them the same cache, and yeah. But yeah, I actually do it that way, but as I said, you can't retime or at least offset a BIF cache, at least not in any easy way, which I experienced on another project, which, as I said, was quite frustrating. So in this case, I don't ever really need to export the thing, or if I wanted to render with Arnold on the GPU, I'd have to export to a VDB anyway, and can't directly render the BIF object, which is a bit annoying really, because maybe they could just do the translation to VDB on the fly for that, or implement the BIF object on the GPU as well. I know it's not that easy, so yeah, I do understand why it can't be rendered currently, but yeah, it would be a lot faster than on the CPU. So the smoke sim will have to render on the CPU, at least if you're not outputting to VDB, which you could. That is it. So I actually haven't tested it set up here on the Mac before starting to record that video, so things might break or explode or something. Obviously this will be a lot slower here than on the Windows machine that I actually did it on. Even if it's a really low res sim, it might take a bit. So let's just see what happens. So well, actually nothing happens, which is interesting. So why? Let me just take a quick look at that, and I'm probably gonna find out why it's not working. So back again, that was an easy fix. So there was actually nothing wrong with Bifrost, so it took me a few seconds to figure it out actually. I, of course, to demonstrate some things, I switched to real time. So, of course, it was not evaluating correctly. So, I set the timeline back to play every frame, which you need to do to have simulations running. I just forgot about having changed that earlier. So, if the thing is running and actually displaying every frame, the thing is going to work. So, let me put my textures back here, because I actually turned off Maya in the meantime, because I had to eat something. So let me just here do it, please. Yep. So there are our textures, and now on to the smoke sim. So I'm gonna turn the default light on, because actually the smoke sim doesn't look pretty nice with the Arnold light in the viewport. So let us run through that. So actually the smoke sim doesn't really look nice in the viewport anyway, but it gets the job done. So I'm just gonna let it run through here for a few frames. So there's a lot of turbulence, because the propeller starts to spin, and as you can see, the smoke is dissipating pretty fast. So unfortunately, I cannot cache this at the moment. So whenever we want to take a look at the smoke sim, I will have to resim that. I could cache it out, but before I do that, I would like to show you some things that were set up to make this easy to work with on the rig. So if I go into this this P51D Bifrost exhaust graph, this has a few attributes on it. So I could have definitely moved them to some control on the rig, but since this is kind of a little bit of an experimental setup, I didn't. So you gotta select that one to actually work with the sim. So there's simple things. So this time connection Bifrost always has. You would believe that you could maybe put other values in there, or a slow down time, or hook an expression up there, or add some value to your time to maybe read a cache on another frame, modify time with a float math node, or with a add double linear. Whatever you do there, you can't change that. So either it's running with the time 1 node connected, or it doesn't do anything, or it will maybe load 1 frame of your simulation if you're reading a cache, but then nothing more. So they could just hide it because you can't do anything with that anyway. At least not in its current state. Whatever, that's the default time. The start frame is currently at 77, which is the point where the rotator, where the propeller begins to spin in this case. So there's two things I can control. So I can basically make the fluid detail size larger for a fast preview, and I can decide on which frame I want the smoke to start. So if I make the thing division larger, it's gonna look pretty bad, but this sim is gonna run really fast, but of course that's just ridiculous. So 0.025 is kind of what I've settled on, and there's really not that much more detail for that thing to generate with a higher resolution. You would probably do that if you were this close, but then again you would change a few things about the simulation anyway. So you can decide on the start frame. So basically you'd animate the propeller, decide on which frame it is that it turns on. Let's say this was frame 20. So I'm gonna let it run to 20, and as you can see, the simulation starts earlier and it's gonna run through, and it's gonna simulate the smoke, and because this is now on an earlier frame, it's gonna look slightly differently, but as you can see, whatever I put in here, so basically that's a tool, so I can use that easily. I can just expose it to an animator and say, yeah, just put the start frame wherever your engine starts, and you're good to go. You're gonna have smoke and it's gonna work. So yeah, as I said, let me just quickly run through a few frames again, and this is really much slower than on the Windows computer before, but it kind of works. So let's say I want to mirror it to the other side. That's pretty easy. So I don't know where its pivot is, so it's pretty much right there in the middle. That's perfect. So if I want to move it over to the side, I'm just gonna go -1 on the X, and that's it. And I might even, if I need both sides and I don't care for them looking the same, I can really just hook up another output to the Bifrost graph and have two of them in the scene. So if I maybe have that kind of off shot, I wouldn't really notice them being the same smoke sim, but I'd see some smoke over here, so I could do that. In addition, I could just cache out two different versions of that smoke simulation and reuse them on the other side. So there's a bit of manual setup that you have to do. But again, you wouldn't normally expose that on a rig to an animator. But you probably would build a tool where you can just say start it on frame 77 and go, and then probably push out 3 to whatever 20 versions. Take a look at them, decide on one, cache it out as a final version in a higher resolution, have it in the background, have it as a cache, and then just load it in at render time, and you basically have your smoke. So let's take a look at the Bifrost graph. So I'm gonna go to the Bifrost graph editor, and that's the thing basically. So as you can see, Bifrost, as pretty much anything here, is node based, and for whatever reason, Autodesk decided that blue would be a cool color. I'd prefer if it was just gray, but anyway, this is the smoke graph. So I'm gonna start at the end actually. So this is the output. This out volume is connected to this P51D BIF object. As I said, I could put a few more outputs there, so I could have a bunch of them that are just the same simulation, really. There's a few things that get set up here. So basically, at the end of the whole thing, the whole smoke simulation is getting an Arnold volume shader. So it's this BIF exhaust volume material AIV. So AIV for AI volume. So if I just quickly go into the hypershade here and just search for AIV, it's that thing. I also have a tab open for that. So that's an AI volume shader. And fortunately, it can read the fields like temperature, density, etc. from from the Bifrost volume shape and directly shade them quite comfortably. So that's a cool system actually. So that works actually flawlessly, really. So this thing here is kind of usable, kind of not. So this is the file cache. So this is currently set to path through. I could set it to write mode to write out a sequence. I'd have to put in some file name here. I removed it because it only takes absolute paths or an environment variable, I guess. But anyway, it was the Windows path, so I took it out. You could write the cache, read the cache, whatever you want to do. That actually also works flawlessly. As I said, you can't offset the read, so whatever you cache out is going to stay on the frames that it's on, unless you rename that. So going into and there's actually this thing. So for GPU purposes, I also have hooked up to that file cache. So I'm going to cache out a BIF sequence, and then if I'm happy with that, I'm gonna write out a OpenVDB volume sequence. So interestingly, you have to provide the right OpenVDB volume with the actual time of the Bifrost simulation, which doesn't make that much sense. So, for example, why would you cache out frame 20 on frame 10? So I really don't understand why I would need that for a write, but that's the way it's set up. On the other hand, the cache read doesn't have any frame input. So there's nothing I can do about which frame is getting read. So there's these little inconsistencies everywhere, and really the annoying thing is that time is I have to convert time from float to long to put it into the right OpenVDB volume, and really that node should do that conversion internally and itself. So there's really no reason that a frame gets produced by the actual time node that Bifrost uses as a float and then needs to be converted to a long for that. So yeah, there's some things that could be a little bit easier, but it works. So taking a look at the other things that are set up here. So down here are the exhaust emitter shapes. So basically, leave me alone, mail. So basically these are the emitter shapes. So this is just loading in objects by parv, and the objects that it is loading in are actually these objects. So as you might see here, you can't see that in rendering, but in the viewport it's pretty obvious. One of the emitters is only producing a flame, because if I had all of these emit fuel and temperature into the scene, there would just be a huge explosion. So I basically decided on one of them to just produce some of the fuel, and this is going to get ignited, and all of the others are just emitting density. So basically they're just emitting smoke into the whole simulation. So the way this is done, or maybe let me just talk about one thing first. So this input node here is basically the variables that I'm taking over from Maya. So basically Bifrost kind of like runs in the background, and it's actually a framework that is not Maya itself, it's outside. So basically this node editor or this graph editor is basically just communicating with Bifrost in a way. So these variables are basically put into a node in Maya, and they are going to be sent to Bifrost, and this thing here is actually going to take them in again. So that's an input node, and there's this fluid detail size and the start frame. And what I'm basically doing is there's the one simulation at the end, but things get emitted at slightly different times. So based on the start frame that I'm feeding in, which is currently 77, some things will emit 2 to 3 frames before that. There will be some fuel that is emitted a few frames after the initial burst and the like. So basically, if I just make that larger again, but because really we need to see that a little bit larger. So basically, these are just all the inputs that vary this input value and add a few frames or subtract a few frames, and they basically just connected to the start frames and end frames of the source nodes. So that's what makes this graph a little bit messy, because they kind of like have to crisscross everything here, so that's okay. Can't do much about that. If I want to have it as a tool where some parameters can be changed, that's okay. So down here is the actual simulate aero thing, and that's the actual solver that's doing the smoke simulation. It has a few inputs. So there's this adaptivity thing, and there's also the solver settings. So that's basically where you set up how your simulation is going to be solved. So you can set something like a style, which is pretty cool. So you can vary the look a little bit, whether you want it fluffy or wispy or something like that. You can change some general parameters about the simulation, the time steps, anything that is a setting that is going to be fed to the solver, really. And I actually like that this is kind of like put into a different node, and they all feed into this solver thing. And the other thing is the combustion settings. So that's where you basically make your settings on how explosive things will be if fuel is reacting with heat and temperature in the simulation, and how much of that heat is going to be transferred through radiative means, or how much soot is emitted. So by the reaction, by the burning flame, there will again be density basically emitted into the simulation. So that's a kind of cool setup. So before taking a look at these things, those emitters, they are basically feeding into 2 source air nodes. So the first source air node is basically responsible for just basically building density for a little bit of fuel to be emitted into the simulation. So everything this upper graph basically does, it's taking one of the emitters, this one, and it's sourcing some density into the simulation. So that's the set fog density right here. I'm going to set a temperature, and this temperature obviously is higher than the ignition temperature used for this fuel node right here. There's actually 2 fuel nodes, because the one thing is emitting fuel right at the start of the simulation, and then the other one is again just introducing a little bit of fuel at a later point in the simulation. So basically these are 2 fuel emitters that are kind of like offset in time. The settings are kind of arbitrary. They worked in my case, but again, there's not really that much going on there, but it looks good rendered. So in the end, if we just compare that again, so if we take a look at some frame, as I said, that's not really a complicated sim, but it works for what it does. So and it could be pushed a lot more. So really, that's a quite robust system. So yeah, this is basically emitting the fuel, and because everything else is basically hotter than this ignition temperature, this thing is going to combust, and how this is going to combust is basically defined in these combustion settings. And down here, here are some things that just vary source properties like temperature. So things that are emitting more smoke into the simulation basically vary their temperature over time a little bit. So there's a little bit more what should we call it? It's varying just some things to give it a little bit more life. And this thing here is again sourcing air. So a little bit less, but this is basically building the larger pile of smoke right here. So basically everything here that is not fuel and not ignited is basically just smoke that's coming out of the exhaust pipes. That is basically introduced by this source air node. So these source nodes, they have wind and initial speed. So basically the smoke at the beginning of this simulation, and let me just change that here. So I'm going to put that to frame 20 so that we don't have that much pre-run. And sometimes you have to nudge the timeline a little bit to make your initial frame reset. So this is just gonna go through and emit the fuel on frame 20, and you can see just this first puff of fuel and the second. So that's basically why I have these two emitters, kind of like a little bit time shifted from each other. So please, Maya, react to the stop button. Okay, so escape. So ran a little bit too far here actually, but as you probably saw, so if I go back here and let it run again, as you can see, the smoke is emitted pretty fast to the back. So because this is coming out of the exhaust pipe at a pretty high speed, and pretty much right after that, so not in this case because I shifted the first frame, but the propeller is actually beginning to spin, so it's even more pushing the smoke back. So that's done. Leave me alone, mail. Again, so I don't know what's happening right now, but it seems to be the time where all the emails are coming in. So sorry for that, but yeah. So right here, so the simulate arrow node has something called influences. So you can hook up, basically chain your influences that will gonna in turn influence your simulation. So in the end, there's the turbulence. So basically the turbulence is gonna create all those little swirlies right here to introduce a lot of motion, because as soon as the rotor spins, there's gonna be a lot of motion in the smoke, basically. So there's gonna be there's a wind influence. So basically the wind is just pushing the smoke to the back even more, and there's this dissipation influence that is just kind of like dissipating the smoke over time. So it disappears and doesn't linger around everywhere. So actually that's the whole setup. As I said, so this is actually a more defined smoke simulation than I did for the actual shot, because as I said, actually in reality there's really not that much going on when the engine starts. There can be a bit of more smoke but less fire, but really you can basically do whatever you want here. So as you can see, that actually works. I could push the resolution a little bit, change some parameters on the shader. What's really nice is the fact that when I go into the hypershade here, let me just quickly select. Could you please let me put it in Maya? So some I always forget I have this tab actually, so that I don't have to search for it. So if I select the shader here, the nice thing is that that could be a first in actual usability. If I change the parameters on the AI volume shader, I do have direct feedback in the viewport. So this is respecting Arnold in the way that Maya should, because Arnold is its default renderer. So you can basically control your whole shading attributes via the AI standard volume shader. So that's pretty handy. So as I said, there are really good things about the system, and there are still some really quirky things about Bifrost. But in the end, in the end, I didn't have to switch my application. I didn't have to simulate the smoke somewhere else. I'd still do that for something way more complex than that. But, well, you're not forced to use old Maya fluids, which are really, really old. They still work. So I've used them. Well, maybe the last time I used them was probably 1.5 years ago on a project, and they still did their job, and they actually worked fine for what they had to do. Especially if it's not smoke sims or something like that, but you just need a cloud layer or something like that. Combined with Arnold, it works pretty well actually still. But yeah, this is Bifrost, and yeah, it kind of worked in that case. So that's basically it for the simulation part of the whole thing. Let me just quickly set that back to frame 77 where the engine actually starts. Go back to the first frame, hope that it resets, and it does, and then just let it run. And then I'm probably gonna speed that up later so that you have a close to real time impression of that lingering, flamey, smoky thing. So, the next thing that we are gonna talk about basically will be the shading. So I'm gonna hide that sim group again and start the next chapter.